So it's time to create our pinball project. I want you to open up the engine once more, but this time I want you to go to New Project and go to Blank. And we're going to create ourselves a new blank project to build from. So I'm just going to go here, and I'm also going to set up down the bottom, I'm going to tell it to save to a specific folder, and I'm going to name the project Pinball. I'm also going to say no starter content because it's not really necessary given that I've provided assets for this, and maximum quality and desktop is fine. So with blank selected and this selected, I'm going to click Create Project, and now we're just going to wait for it to load up. Now that the project's loaded up, you can see that once again we're greeted with a completely empty interface. We have nothing really here apart from a player start, a sky dome, a box, some fog, and a light. Now, in the long run, I'm going to be removing all of these things, but I'm going to keep them around for the time being just for the sake of demonstration. The first thing I'm going to do is in my content browser, I'm going to click on this button here to show the sources panel. Now if you can't see your content browser, go to Window and make sure it's enabled here. Keep in mind that this layout is completely variable. If I didn't want to have something, I could close it, or I can just drag it around and put it wherever I want. I find this to be the simplest way for demonstrating things though, so I'm going to keep mine like this. Now I'm going to right click on my content folder here, and I'm going to go New Folder, and I'm going to call the first one Assets. I'm then going to right click again, New Folder, and I'm going to call this one Blueprints. So to begin with, let's quickly just import the ball mesh that we're going to be using for our pinball. So I'm going to open that up, and I'm just going to import the mesh itself. So by dragging this in, now be aware that you're going to have a little pop-up as you first drag it over that says that it can't accept it, but after about a second or so it'll turn to something that will allow it. So when I drag this in, I'm just going to set a few things. I'm not going to import materials or textures. I'm also not going to automatically generate collision for the mesh. In this situation, I believe I can just import normals and tangents. Everything else by default should be fine. Yeah. So I'm going to click import. It's going to throw a smoothing group warning for me, but in this situation it's totally fine, so we're not going to worry about that. So to begin with, we've got ourselves a mesh, but I really want it to look like a pinball, so I'm just very quickly going to whip up a material for it. I'm going to right click, I'm going to go New Material, and I'm just going to call this M_simple metal. Going to double click on that, and we're going to be greeted by this. So luckily our sphere here is actually pretty much identical to our actual pinball sphere. So I'm going to go to this and I'm going to set this up to be metallic. Now if I hold down 1 and left click, it's going to add a constant variable. So by 1 and left click, you'll see that it adds this node. Keep in mind that anytime I add any of these things, you can also search for them up here within the palette. Now the first thing that I'm going to do is I'm going to set this to have a roughness of around 0.25. You can see that the second I set the roughness to a low value, this got incredibly reflective. But I'm going to set this to 0.25 so that it's not quite as reflective as that. I'm also going to set the metallic by default to be a value of 1. And of course, upon doing that, I'm then also going to need to set up a base color. Now, I could drop in a number the same way I did for these two by again holding 1 and left clicking. Or alternatively, I could actually make it something that can be modified outside of this within Blueprint itself. So something that could be changed in-game for one reason or another. So to do that, I'm going to hold down V instead and left click. Now if you don't want to use the keyboard shortcuts, you can always type in the word vector param, and you'll see the vector parameter can be just dragged in. Now a vector parameter gives you a couple of output pins here. Essentially, I read into it a red, green, blue, and alpha value, and it will output me things. But you'll notice that again there's an extra channel. So how this works is the red, green, and blue channels all respond to their colors. This bottom gray channel refers to the alpha channel, and this top white node actually outputs the color. So it outputs the combination of these nodes together. So by plugging this in, the top one, into base color, I'm going to go to here, I'm going to name it color, and I'm also going to click here and just give it a base color. Probably going to set it up to be a little dark. That's good enough. And if we wanted to, we could theoretically tint it as well, but I don't actually want to tint it because I want my pinballs to look reasonably just gray. So I've hit OK, and we've got ourselves a simple metal. So now if I hit save, I'm going to go back to my ball sphere and I'm going to double click on it. Now, the first thing that's worth noting is that the material is not applied. So I'm going to go up to here and I'm going to apply it. Now, here's the thing with this right now. If I was to go and drop this in the world, it's actually not going to let me tell it that it's a physics object. See how down here this is grayed out? Now the reason it's doing that right now is because I didn't import collision when I imported the ball. And the reason I didn't import collision was because if I imported collision, it would try and wrap a squared off shape around my perfectly spherical object. And instead what I'm going to do here is go collision, add sphere simplified collision. And that's now going to add a nice simplified spherical collision to my mesh. If I go back into here and I click on this, you'll now see that simulate physics is actually an option. Now the reason that I'm setting things up this way first is so I can quickly demonstrate a point. And that is that if I tick simulate physics and I click simulate, you'll see that the ball just drops to the ground. Now the problem is that if I wanted to make an actual pinball map, I would really need to have a nice angle to correctly get the ball bouncing and then adhering to the ground. And you know, that would work. There's nothing inherently wrong with that, except for the fact that it does make it a whole lot more difficult to create levels that are at an arbitrary angle. So what I'm going to do instead is I'm going to develop a flat level, and then I'm always going to give the ball velocity towards the bottom of my screen. So this is where blueprint comes in, and we're going to have to create ourselves an actual object. So we're going to have to create ourselves an actor in the world that has certain properties that we're feeding information to. So I'm going to go to my blueprints folder, I'm going to right click, and I'm going to click new blueprint class, and I'm going to create an actor. I'm going to call this BP underscore ball. Now when we create our first blueprint, we can open it up by double clicking on it. Now if I go to the viewport class, this is where we control any of the components that are being added to the world, and we can get a good idea of what it's actually doing. So we can see it within here and move things around, change where things are located, and really make sure that everything looks correct without having to test it in the world over and over again. The first thing that we need to do is make sure that this has a mesh applied to it. See, at the moment it has this simple white ball, but that's not actually a ball. If I was to drag this into the world and hit play, we can't see anything. It's purely there for the sake of us knowing where the blueprint is if it's just code-based. So I'm going to go to here and I'm going to add a component, and the component that I'm going to add is going to be a mesh. Specifically, it's going to be a static mesh. So I'm going to click here and I'm going to call this ball. I'm also going to go ahead and at the moment this is the scene root and the ball bases its position on the scene root. I don't actually want that to happen. Instead, I want the ball to be the root of the scene, so anything that's ever added to this will be based off of the ball's position. So I'm going to drag the ball upwards, and it's now going to make it the root component. Now obviously our ball's missing something, you know, the actual mesh. So to get that, we go to the right hand side here, and in our details panel, I'm going to click here, and I'm going to select ball sphere. And there we have our ball. Now, with our ball added, what I'm going to go ahead and do is by default, we want it to simulate physics. So I'm going to enable that. There are other things that we will need to change later on, but for the time being, this is all we need to have within the world. So if I go back here, you can now see that that actor that was in the world is now actually my ball blueprint. And if I hit play, it'll fall to the ground because it knows to simulate physics by default. Now when it comes to Blueprint script, it's very important to know that there are two areas that you can work with. You've got the construction script and the event graph. Now the construction script handles all of the things that you would want to run when a Blueprint class is created. For instance, you may want to run script so that when I add a fence actor to the world, it executes that script and then automatically creates a fence to the nearest wall. Now the event graph, it contains all of the code relating to gameplay events. So the event graph is typically what you would use in most cases when you're making something in Blueprint. Now, within the event graph, you've got two things that are very important that you keep note of. You have begin play which runs before the initial gameplay tick of the actor. So this is the event that fires the second the game begins, or if the game's already running, it's the event that fires the second that actor kind of enters play. The other thing that's important to note is tick, because tick is the function that runs once per frame per actor. Now, this can be disabled, but essentially what this means is that after begin play has run, tick runs, and every single frame, so every single time the computer is updating, it ticks every actor again and again and again. And what's also very important is that the time between ticks, so the time between your computer updating all of the actors again and again, is called the delta time. Now what I'm going to be doing here is I'm going to go to my event graph, and I'm going to actually go and modify the function called tick, because I want this to always be moving in a very specific direction. Now, because ticks have a variable associated with them, that is that we never know exactly how long a tick is going to be between now and the previous tick, we have a nice little thing called delta seconds, which is what we use for controlling that. So what we're going to be doing here is I'm going to go and right click, and every single tick we want to add an impulse. Okay, so I'm going to type add impulse, and it's automatically going to give me anything associated with the words add impulse. And in this situation, the one that I really just want to add is going to be simply add impulse ball. And you can see that by default, not only has it added the node, but it's also, because ball was in brackets, it's gone and added this as a reference. So what this essentially means is when something touches this pin here, the exec pin, it's going to add an impulse that's given in this category here to the ball. Okay? Now, what I want to do is I want to tell it how much of an impulse to add. So the thing with doing that makes this kind of tricky is that by default I want that impulse to always be I want it to be roughly 2,000 units downwards every second. But that means that I'm not actually going to be adding 2,000 units downwards every tick. Instead, I'm going to be adding 2,000 multiplied by the fraction of the second that it is. If for some strange reason tick was, say, half a second, it would be 0.5 seconds multiplied by 2,000 is how much of an impulse we would be adding. So in this situation, what I'm going to do is I'm going to create a variable that is simply going to be called default speed. I'm going to set the variable to be a vector, and it's not going to let me do anything with that variable, but that's okay. If I click compile, you can now see that these have all been filled in. Now the default speed that I want is going to be negative 2,000. So I'm going to drag that into the world, and when I drag it into my event graph, you can see that I can select get or I can select set. In this case, I want to get the value of default speed, and all I'm going to do is multiply the output of tick. So I'm going to type in an asterisk, which gives me the multiply symbol, which allows me to go, I want to multiply a float by a vector. Okay. Now the reason for that is that delta seconds is what's called a float. So there are two types of standard numbers that you can really store. You've got integers, which refer to whole numbers, and floats, which refer to numbers that can have a decimal place. In this case, I'm going to go delta, so vector times float. And when I click on that, you can see that it's added a nice little function here that allows me to multiply a green variable against a yellow one. So I'm going to connect these two, and then I'm going to plug that into my impulse. Just going to rotate these around a bit so it's a bit nicer. If at any stage you want this to be prettier, you can double click on the wire itself, and it'll give you a reroute node for you to arrange things nicer. I'm then going to connect the exec pin to add impulse, and the final thing that I'm going to do is say velocity change, which essentially says ignore any of the actual mass of the object, just make sure that this is the value that it gets to, and whether it's big or small, move at that speed. So with all of that said and done, I'm going to hit compile and save, and I'm going to add the ball to the world, and I'm going to hit play. And you can see that immediately it's flying off down the y-axis.